Okay, so I'm going to start this up now. So this is the carbon detritus. I'll try and find the boundary. Let's see. That looks like it might be the cut boundary. Zoom out a bit. And there are some lighter particles in there. Hopefully they're not just detritus from the cutting. This looks like a large carbonaceous deposit on the inside of the exhaust pipe. And that's the other cut bit. Don't see anything like I saw on the inside of the Thunderstorm generator inside of the outside. But we will have a look around. Looks mostly like a big blob of carbon deposit. Still, going to check the whole area. Right up to the other cut edge. Don't really see anything of much interest here. Getting a little out of focus because it's bent. Curved bit of pipe, of course. Okay, hold on, we got some candidate things down here, so let's have a look at those. What are they? Whatever they are, they're very buried. Still. Okay, 1, 2, 3, whatever they are, put that on slow, see if we get any better idea. It's worth taking a look. Are they fragments from the cut surface? Possibly. We'll take a shot at that. Okay, so this clearly looks like a particle here that's been dragged across the surface there. Something here maybe, something here. We'll have a look. Okay, so I will zoom into this. Boom. Well, it's not that interesting. Go down a little bit, see if you can see something else. It just look like more agglomerations of this carbonaceous material. What is that though? Let's have a look at that one. What is that? What is that? That looks more like a fragment of the cut. Yeah, I wouldn't call it an iron-rich crenellated sphere. Looks like a chip from the cutting process. Okay. Not very interesting. Okay. What is this slightly chunky little blob here? Anything interesting? Not really. Anyway, what we will do, just for the sake of argument, is we'll have a look at this. See what it is. See what the whole area is. Who can say? But I suspect it is going to be carbon-like. Okay. There we go. Right, let's bring this over to the EDS. Thank you very much to Alan Goldwater of Magic Sound Labs here in Santa Cruz, California, for providing the equipment and the sample from the old motorbike exhaust. So I think we'll take a sample of this area here, this one, and we'll take a sample of this area here. What have we got? Okay. So, the first one has a minuscule amount of calcium, some phosphorus, sodium, is that really calcium? Maybe. And over here, this does look like a little splodge of iron. Is that right? And it should have carbon in there. So if we add iron in, no, it's not iron. What is that? It's zinc, is it? Looks like it might be. And that's probably not sodium. So for some reason, there's zinc in here. Maybe there's some zinc in the engine somewhere. Maybe some of the metalwork was coated with zinc at some point. Looks like a bit of sulfur there, small peak. And that's about it. And then this one, looks like it has more zinc, essentially, and something here, more calcium, and then more sulfur. That is about that. So I expect some of the metal in there had zinc in it somewhere. Not a lot else. Reasonable count number. No signs of titanium or iron, chrome. Okay, so we're going to stop that. I think what we'll do is we'll go here and we'll go add to report, add to report, and then we'll go here, add to report, and add to report, and then over here we'll go add to report. So we should have both of ours things here, and then this one. Cool. Right, next, let's see if we can find something else that's a little bit more interesting. Big crack there. So what is that? It's on the cut line. Let's go into the body of the material here. What are we seeing? We're seeing anything that looks like a crenellated sphere. Two kind of roundy blobs down here. Let's take this one that looks like the more round of the blobs. Okay, boom. And it's kind of like there. It's a itty bit about out of focus, so. What have we got here? Well, it's closer to being a sphere than a straight blob. I wonder if it's going to move like the last one apparently did. Let's see. Auto. Not seeing it myself. Not seeing it myself. Oh dear, it's moved again. It's a jumpy particle. That's not good. Cancel. Where did he go, my friend? Where did he go? Huh, is that you down there? Did you jump all the way down there? Maybe. You're going to jump again. Those particles like to jump. Maybe I'm going to have to do a quick save here. Or something like this. Let's actually do a focus on it first. Are you going to jump on me now? Right. Fast. Boom, 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 boom. Don't jump. Don't jump. It's when you put the imaging on here. A lot of high energy electrons hitting it can sometimes make it jump. Some program trying to take over. Oh dear, looks like it might have jumped. See a little glitch there. No, it's still there. Okay, we'll try and capture it over here. We'll just do a point sample, or a small area sample, so that it doesn't jump. Kind of like this little circle in here, what that is. Don't know. Little circle structure here as well. But we'll focus on this one. Kind of look like calcium or something. One there, and the one over here. Why not? Select all, acquire. Yep, calcium. And the zinc. Same kind of material. Fairly consistent picture with samples on here. Not really, there's no sodium there. It's confused with the zinc. Well, same sort of story. I'm going to stop the acquire there. Same procedure. Add to report. Add to report. And click. Add to report. Add to report. And add to report. Good. Everything we want. Good. And one last effort to try and find something. This is not like looking for balls as it was on the Malcolm Bendall device. Now there is a little thing here which could be a candidate here. What are we looking at there? Very much out of focus, but can deal with that, hopefully. Okay, this looks like a cut from, yeah, it's a fleck from cutting. So it's going to be iron and it's going to be mobile. So are they iron-rich crenellated microsphere that we've learnt to know? Really is deep incrustation of carbon deposit here. Basically soot. Here, 75% by atom percent, 74% carbon, oxygen, almost nothing else by atom percent. More of the same there. Have a quick look to see if we can get a decent image with the secondary electron detector. Yeah, see some detail there. Let's move to a different site. That's where it's cut. So good. Come up to the normal sort of area and I'll do a secondary electron shot. Some of the crusty area, cracked area. There we go. Focus. And we'll do an image. Okay, very consistent, right? Really no different elements there. Not a lot of interest in any of this. Nothing standing out saying, hello, I'm an iron-rich crenellated microsphere. It's the cut edge. No, really is very homogeneous, sooty excretion. That's what the inside of a old motorbike's exhaust pipe looks like. Quite nice, actually. Okay, I think that's probably it. Not the most exciting sample ever. Okay. Don't know what more I can say, really. It's not the best. From the point of view of helping to verify that something interesting is going on with the Thunderstorm generator, this is about as an important test as you can get. If a very, very old exhaust pipe has not seen any production of these things, then one could argue it's not occurring in those standard type of exhaust pipes. And we don't see any here. Nothing even approaching it. Just a few specks of cut dust. Nope. Just specks. Have a quick look at this thing in the crack here, just in case. Just in case. What is that? What is that? Boom. It's a speck of something. Is it interesting? No, it's just a cut fragment. Very dull. There we go. No iron-rich crenellated microspheres on this old interior surface of an exhaust pipe. A lot of carbon though, as we can see from here. Lots of carbon. Just for sake of thoroughness, I'm going to take a whole area scan over here whilst I go and do something else before closing out. Okay, what is that area comprised of? Right. I'm going to leave that for a little while and come back later. Okay, it has been going for some time now, and you can see that if I really expand out the lines, I can possibly see some signals of other elements in there, but really if we pull it down, you can see they are, silicon is 0.18, sulfur is 0.15, iron is 0.09, nickel is 0.09, copper is 0.09, so basically they are not a thing. So we have nickel, copper, iron, they're not really a thing there. No level of certainty. And no silicon. So if I pull the zinc back into frame, or rather carbon. Carbon is the big story here, of course, by atom percent. Then oxygen. And together that comprises of around about 93% of the mass of the material under that sample window, and then the bulk of the rest is phosphorus, calcium and zinc, in the order of phosphorus, zinc, calcium. Of course, if we do this by mass concentration, the zinc is actually quite considerable because it's quite heavy. It's 12% there. Still, the carbon and oxygen is by far the bulk of the material. Of course, we cannot see hydrogen, and so some of these might be unburnt hydrocarbons. To normalize that actually, so we don't get over 100%. Yeah, so that's kind of the figure there. So sulfur really, whilst it's there, it's basically not there. So we go back to atomic concentration normalized, and you can see calcium still falling under, sulfur's basically very little there. Okay, but no iron-rich crenellated microspheres. So with that, I will say thank you very much for your time, and I will see you in the next video.